Welcome to a special edition of NASA Science Live about climate change. I'm your host, Joy Eung, and today we'll be talking to NASA's chief scientist and senior climate advisor about rising heat all over the globe. We'll also hear from climate scientists across the country about extreme heat impacts and how they affect different aspects of our environment, from air quality to oceans, and how NASA satellites and data help us learn more all about it. So this is your chance to interact with NASA experts and have your questions answered in real time. So be sure to send them in using the hashtag AskNASA in the comments wherever you're watching. So today's focus is heat. Air temperatures on Earth have been rising since the Industrial Revolution. Human activities, particularly emissions of heat-trapping greenhouse gases, are making our planet warmer. Heat waves are the clearest examples of impacts of humans on our climate. And it's a fact. Human activities are making heat waves hotter and even causing them to last longer, starting earlier in the spring and extending into the fall. So as a reminder, we are keeping an eye on the questions pouring in online, and we'll bring them straight to our experts live on air later in the show. We also have experts in the comments standing by to answer you in real time. So let's jump in. Now, with me today is NASA's chief scientist and senior climate advisor, Dr. Kate Calvin and John Hayes with NASA's Earth Action Program. Thank you both so much for being with me.
Thank you, Joy.
Thank you.
So let's talk a bit about your roles. Kate, can you tell me what you do at NASA?
So I am NASA's chief scientist and senior climate advisor. So that means I advise the NASA administrator and NASA leadership about all things science and climate. I also work on connecting within the agency and communicating what we do externally.
And I serve as program manager for health and air quality applications, part of the NASA Earth Action Program. And my job is to work with end users, stakeholders, decision makers across the country and across the world to help them access the treasure trove of NASA satellite data that we have on the Earth system and how it is changing, and help them to apply that data to issues and problems related to health and air quality.
Thank you. That's super helpful. So I think the term heat wave can have a few different meanings. So can you explain to us what context we're discussing heat waves today?
Yeah, sure. That's a great question. I think sometimes when we talk about rising heat or more heat trapped in the planet, we're really talking about climate change in general. And so what we know is that climate change is making our planet warmer overall. And with that increase in average temperatures, we're getting a lot of impacts on people and ecosystems. But there's also a specific type of events called heat waves. And heat waves are periods of abnormally hot weather. So they might be a couple of days to months, but usually you think about them as like number of days above 90 degrees Fahrenheit or some other temperature. And that's one particular type of weather event that is increasing with warming.
Yes, and rising heat and heat waves are certainly a big health issue, leading to issues of heat exhaustion, heat stress, heat stroke, particularly hard on the very young and the very elderly. And most people don't realize that out of all the weather phenomena, tornadoes, hurricanes, heat actually kills more Americans each year than any of those other events. And according to the CDC, those heat deaths are on the rise.
That's helpful context. Thank you. So rising heat doesn't just affect one part of our environment here on Earth. It impacts all areas of the globe. So at NASA, we have scientists who study the whole picture, from ice sheets to air quality, from oceans to droughts and wildfires. And as I mentioned earlier, throughout the show, we're going to be checking in with scientists across the country to learn about how rising heat is impacting our planet in different ways. So let's start with Dr. Ben Cook in New York to get an update about rising heat, how rising heat affects global temperatures and what that means for droughts, wildfires, and agriculture.
I've been studying how climate change and global warming affect drought and wildfire for most of my career. Over the last several years, we have broken numerous temperature records at the global scale, and with them, established new records in drought and wildfire in many regions of the world. Warmer temperatures dry out the land surface, and as a result, global warming has increased the severity of droughts and wildfires in regions as far apart as Western North America, the Mediterranean, and Australia. At the same time, climate change has also contributed to the increased frequency of co-occurring heat waves and droughts, a double threat that amplifies the impacts of these extremes on people and ecosystems. As global warming continues, we can expect drought and wildfire to continue getting worse.
Thank you for that update, Ben. So NASA and NOAA release global temperature updates regularly each year. And as Ben mentioned, the most recent report was just released on June 11th and indicated that May 2024 was the warmest May in the books, marking a full year of record high monthly temperatures. So Kate and John, can you explain how NASA and NOAA determine these sorts of trends?
Well, from the NASA standpoint, we have a constellation of over 20 satellites and sensors in Earth's orbit, including several on board the International Space Station that are continuously monitoring Earth's weather, climate, and environment for research and applications purposes. This constellation is actually the largest civilian Earth-observing constellation that the world has ever known, and we get a ton of data on the Earth system and how it is changing, downloaded every day from that constellation. And that data gives us information on things like land surface temperature, ocean surface temperature, vegetation density, air pollution, wildfires, you name it.
And we complement that data that we can get from space and observing our Earth from space with data that we collect on the surface. And so often when NASA and NOAA talk about monthly temperature records or annual temperature records, they're looking at the surface data, and we have surface stations all over the planet that monitor temperature, and then we can calculate that average temperature for the planet. And we use those surface records because they go back farther in time than the satellite records. But when you compare both satellite records and surface records, you see the similar trends in warming.
So Earth also goes through natural cycles of warming and heating. How do scientists know that this global warming trend that we're seeing isn't the same thing as that?
Yeah, it's a good point. So, we do go through natural cycles over very, very long time scales, think tens of thousands of years. And that has to do with the tilt of the Earth, its proximity to the sun, and those things affect the amount of sunlight coming in, so how close you are to Earth. What we're seeing now is more heat being trapped. And what we know is we can look at different types of evidence. So we can look at observations, we can look at models, we can even do laboratory experiments. And they all show that increases in carbon dioxide trap heat. And we see when we look through those observations, if you had more sunlight coming in, you would expect warming throughout the atmosphere. What we're seeing instead is warming at the surface and actually cooling in the upper atmosphere, which is a characteristic of trapping heat associated with greenhouse gases.
And when you're talking about heat waves and rising heat from, of course, greenhouse gases that are trapping more heat near the surface, it's only amplified in urban areas where the vast majority of our population lives. Because urban areas, of course, are full of asphalt and concrete, and that absorbs all that solar radiation during the daytime and slowly releases it out at night. So we're in the urban areas actually amplifying heat effects, and also our cities aren't cooling down as much as they used to at night, so it doesn't give anybody a break from the heat anymore.
Mm-hmm. So we do have some questions coming in online, so let's dig in. So we do have a question from YouTube from Lynn, and they ask, how is this going to affect southern states in the U.S. like Mississippi and Louisiana?
Well, there's a myriad of effects, unfortunately, that we're going to see in the southern states, and I'm actually a Mississippi boy myself. Of course, the South is hot, but it is getting hotter. In conjunction with that, we're also seeing more extreme variations in weather events, from devastating floods to long-term droughts. Another issue, of course, is hurricanes. Unfortunately, Mississippi and Louisiana have been devastated by many terrible hurricanes over the years, including, for example, Hurricane Katrina. When you're talking about the issue of the climate crisis and hurricanes, one of the things you have to think about is sea level rise, which I know we'll get to a bit later. But as our sea level continues to rise, you're adding that on top of the storm surges that are already coming inland from these storms, pushing further inland than we've ever seen before.
So our next question is on X from Sea Escape, and they ask, what is the immediate solution to cool down the Earth's rising temperature?
One of the things as scientists, since we know what's driving the temperature increase, we also know how to limit that temperature increase in the future. So the warming of our planet we're seeing is driven by greenhouse gases. So in order to reduce the rate of warming, we need to reduce greenhouse gases. And if we actually get to the point where carbon dioxide is effectively zero, we would stop warming.
And another question on X from Space Fabrics. They ask, how do these record-breaking heat waves impact our everyday lives, and what actions is NASA taking to help us understand and address these extreme weather conditions?
Well, number one, like I mentioned earlier, it's on your health, not only from heat stress, heat exhaustion, heat stroke, which kills more Americans than any other weather phenomena each year, but it also impacts the very air we breathe, and having more increased levels of ozone, for example, in our urban areas. So those are two ways it directly impacts human health from these events.
One of the ways that NASA is really working to help with climate changes is in explaining it and providing information. So John mentioned that we have more than 24 satellites and instruments in orbit. All of the data we get from that is publicly available, and we're working to make it easier to use so people can understand what's happening where they live and then take steps to address it.
And not only do we make it publicly available, we work directly with stakeholders and decision makers from state departments of health and environmental quality all the way up to the CDC, EPA, even international groups to get this information out and into their hands so that they can make better forecast decisions, management decisions, policy decisions.
Well, that's wonderful. So we have another question on YouTube. They ask, in India, sometimes the temperature rises to 45 degrees. Is this normal for the temperature to rise so much? And like 45 degrees Celsius.
Yes, obviously. Yeah, I think one of the things, as we mentioned, is that what we're seeing with climate change is an increase in average temperature, but also more extreme heat events. And with each individual event, scientists actually look pretty carefully at, like, has this happened before? What was the likelihood it would happen before? And what is the likelihood that it happens now that we have a warmer planet? And try to understand what's driving individual events. But overall, we know that there's a trend towards increased temperatures on our planet, including increased extreme events and extreme heat events.
Mm-hmm.
Yeah, going hand in hand with the heat wave, we have just recently kind of ended here in the Northeast and Mid-Atlantic. Washington, D.C. hit 100 degrees Fahrenheit, 38 degrees Celsius, for the first time in 8 years, with a very long stretch of 90-degree Fahrenheit plus days. And again, these heat waves are becoming longer, more intense, starting earlier, lasting later in the year. At the same time this was going on, there was another severe heat wave in southeastern Europe as well, where temperatures were well above 38 degrees Celsius in Greece, for example, and led to a lot of deaths of hikers and tourists.
So we have another question from YouTube, from Maddox. And they ask, are the record high temperatures and global warming confirmed to be from pollution and not simply a high point of activity from the sun?
This is actually one of the things we really monitor, and you might even hear lately that we're headed into solar max. That has to do with really solar flares coming off, which could lead to impacts on electronics, or more aurora, so northern lights or southern lights. But we can measure the amount of sunlight coming in. We can also measure the amount of heat going out. And because we can do that, we can help understand what's driving warming. And what we're seeing is more heat being trapped over time because of this increase in greenhouse gases in our atmosphere.
So another question from X, Orwell 2022. They ask, can you explain how you deal with urban bias, or the bias created by the urban heat island effect when making climate measurements of factors like surface temperatures? And how do you ensure that climate measurements are credible and not extrapolating UHI to other rural areas?
Well, as Kate mentioned earlier, it takes not only the Earth system, it takes a system of data. And that includes ground measurements, includes data we get from our airborne campaigns that are including over the oceans. And then you have the piece from our unique vantage point in space, our satellites on orbit. Because there's only so many ground stations across the world. We have a pretty good density of them in the United States, but there's a lot of places in the world where there just aren't any ground sensors. So we have to use all of this information, including our global vantage point from our satellites of the Earth system and how it's changing. And like I said, we get information from those satellites on ocean temperature, on land temperature. And so we're able to see the entire global picture. So we're not biased by just ground measurements alone and not just point data, because we're getting a truly global picture from our NASA satellites.
Mm-hmm. Yeah, and just one of the nice things about satellites is it does see everything. So not just the places where we have surface stations, but the whole planet. And then as John mentioned, we use these different methods. We also have different people around the world that do the same types of calculations independently. And we're all seeing the same trends. And that's the way one of the ways that scientists verify what we know. We measure it in different ways. We look at it in different ways. We have different people approach the same problem from different perspectives. And when we see the exact same trend in all those ways, we know.
Mm-hmm. So we've been talking about global temperatures, but I have more of a general question. Derek from Maryland asks, what are the 3 greatest changes society can make to reduce the impact of climate change?
That's a great question, and it's one that we get a lot, but it's actually, to answer it, we can answer it in a very scientific manner, and we know that the largest driver of warming to date is carbon dioxide. The second largest driver is methane. So, reducing warming in the future, you can reduce carbon dioxide or methane. But with respect to specific actions, each of us are different. We each live in a different place. We work in a different environment. We have access to different options. And so it's hard to know exactly what works for an individual without knowing about their life. But in general, actions that have lower emissions will lead to less warming in the future.
And, we say often you have to act locally, but think globally. And in our urban areas, particularly, while, again, you're not going to be able to completely mitigate the effects of the urban heat island, but there are things that people can do to help on the margins, make it a little cooler in the cities. Urban gardening is a big deal right now. In fact, my husband has a big urban garden on our balcony. And having these green spaces on balconies, rooftops, having larger, city parks and more green spaces, areas where people can get shade, does help at the margins keep our cities a little cooler.
Mm-hmm. Those are both really good points. Thank you. So let's check in on our planet's ice, which is an important part of the global climate system. To give us an update about the changing landscape of Earth's ice, we have polar scientist Dr. Ben Hamilton from NASA's Jet Propulsion Laboratory in Pasadena, California.
As the climate continues to warm, rising surface and ocean temperatures affect ice in many ways, including in our polar regions. I have been studying sea level change both on a global scale and also on a regional scale. Using satellites, we can see that sea level is rising almost everywhere on Earth. Not only that, the rate at which it is rising is increasing. It's like we're putting our foot on the gas pedal. These changes have a big impact on people's lives. Many low-lying areas around the world are already experiencing flooding. And as sea level continues to rise, we expect this flooding to increase in frequency and worsen in severity. A really big part of the sea level rise that we are seeing comes from the Greenland and Antarctica ice sheets, which are home to most of the world's ice that accumulates on land. Combined, these 2 ice sheets contain enough ice that if it were to melt all at once, sea levels would actually increase by 215 feet. While that definitely won't happen anytime soon, even an additional foot of sea level rise would be a huge problem for the planet's coastal communities.
Thank you, Ben. That is a lot of disappearing ice. So, Kate and John, can you tell us more about how the melting ice at the poles, how does that affect the everyday person watching the show today?
Yeah, and so one of the things that happens when ice melts, if the ice is on land, like in Greenland and or Antarctica, when it melts, that water runs into the ocean. So then we have more water in the ocean, and that's contributing to rising seas. And the rising seas are impacting people all along the coast because we have higher water levels, which also means that when you have storm surge or flooding events, you're starting from a higher base of that water. And so it is impacting the people that are living on coasts all around the world.
And when you get these extreme events, for example, I'm sure many of viewers are aware that over the past couple of years, there's been multiple 1 in 100+ year flood events in southern Florida. When you get these extreme precipitation events, because a warmer atmosphere holds more water vapor and the precipitation comes down, most of these cities are set up for that storm water to be collected by canals and discharged into the ocean. But now our ocean is at the same level of those canals, so there's nowhere for the water to go, so it just backs up into Fort Lauderdale and Miami.
So we have a few questions about that online, so let's dive in. Ian on X asks, can you explain geoengineering? Is it making our weather hotter?
So one of the things, so when scientists, when we talk about, we use very precise language. And so often, rather than using the term geoengineering, you'll hear scientists use either carbon dioxide removal or solar radiation modification. So what carbon dioxide removal is doing is it's taken carbon dioxide out of the atmosphere. And by doing that, you can either slow the rate of warming, or if you take enough out, you can actually reverse warming. But you're removing the greenhouse gases that are trapping heat when you do carbon dioxide removal. So you're stopping the driver of warming. The other type of geoengineering, solar radiation modification, sometimes called solar geoengineering, that is blocking sunlight. And there's different ways of doing it, but by blocking the sunlight, you could you could reduce temperatures, but you're not reducing the underlying driver. So things like ocean acidification still happen because you still have carbon dioxide in the atmosphere. And solar radiation modification can also have a lot of impacts on other aspects of our Earth system, like precipitation or ecosystems. So there are a lot of other consequences and effects associated with solar radiation modification.
So we have a question on YouTube from Richard Locke, and they ask, by how much do each of you think the planet's average global temperature will warm by, as it looks, 1.5 degrees Celsius? Does it look like the 1.5 degrees Celsius target is completely unrealistic?
So I think first of all, often when you hear sort of annual temperature updates, those are very different than when we talk about the 1.5 degrees Celsius that you hear talked about in media. That 1.5 degrees Celsius is a 20-year average usually, and so that's a bit different. And so one of the things that scientists do is we actually look into future warming, and so we can look at under different potential scenarios for future, the way that energy, water, land, and emissions evolve, we can look at the temperatures of those. And when we looked across all of that a few years ago, what we saw was that 1.5 degrees Celsius would be reached in the near term, so in the early 2030s. But how much warmer it gets depends on future emissions. So what warming we see in 2040 or in 2050 depends on what actions are taken between now and the future.
And, we're seeing the impacts now. It's kind of unfortunate. If you went back 20 years, people would say, well, in 2020, 2030, you're going to see these events. Well, the future's now, and the future has already arrived. And for our children and our next generation, that is the future that they will live in the 2050s, 60s, 70s. But we are already seeing before our eyes what the impacts are occurring right now with these extreme flood events, for example, with these longer heat waves, intensification of urban heat island. And so it's very important to keep in mind when you hear about these longer term climate forecasts, some people might be saying, well, that's a long time in the future, but it's coming for us really quickly.
So Aya on X asks, you mentioned the Mediterranean area. I'm from Turkey, and especially this year, the temperature is getting higher and higher, even through July and August, which are still ahead of us. So do you think the temperature will keep increasing in the coming years?
Well, undoubtedly, it will. Our current trajectory for greenhouse gas emissions globally certainly supports undoubtedly that the temperatures will continue to rise. And we will see, again, rising heat on average, longer heat waves that start early in the year and last later in the year. As I mentioned earlier, I'm so sorry for the folks in Turkey and Greece. They have been suffering under an extremely intense heat wave that has caused a lot of deaths. And it is areas that, yes, it gets hot in the summer, but this type of heat this early in the year is not expected. As a meteorologist, we usually say weather's what you get, but climate's what you expect. So the weather's what they're getting, but it's not what you would expect.
Yeah, and as John mentioned, we're seeing a general trend in increasing temperatures because of climate change, and we would expect that trend to continue as long as greenhouse gases continue to rise. But we do still have natural cycles on top of that, like El Nino and La Nina, that can lead to warmer or cooler years. So every year in the future might not be the hottest year on record, but we're seeing an overall trend towards hotter years overall.
So I have a question from Nathan on X, and they ask, how much impact do humans have on temperature versus the natural phenomena? Also, what happened to the hole in the ozone layer and fears about acid rain?
So effectively, all of the warming we're seeing to date is due to human activities. So all of it, we can actually look at individual contributors and see how much is from carbon dioxide versus methane, and effectively all of the warming is human caused. For the ozone layer, I don't know if you want to talk about that.
Well, talking about acid rain and ozone is a good news story. And we need to talk more about good news stories of what this globe can do when people get together and tackle a solution that is based in scientific data. I asked, in fact, at a conference a few weeks ago, it was some people younger than myself, and I said, have you ever heard of acid rain? No one raised their hand. Because I think that was one of the biggest environmental issues when I was growing up in the 70s and 80s. What happened to it? Did it just disappear by a miracle? No. Our regulations under the Clean Air Act helped us regulate sulfur dioxide produced by our factories, where now sulfur dioxide levels in the United States are 80% and more below what they were in 1980, which leads to not having acid rain because you're not pumping sulfur dioxide in the atmosphere. The ozone hole is another one. Of course, a huge issue, still an issue, but a huge issue that came to a crucial crisis point in the 1980s when we realized that chlorofluorocarbons, when they entered the stratosphere with the extremely cold temperatures there, particularly over the Antarctic and Arctic, it leads to the destruction of the ozone layer that is our protection from the sun's UV radiation. The globe was able to come together through treaties like the Montreal Protocol to eliminate CFCs worldwide. And now, from our NASA satellite data that first discovered that ozone hole, we've been watching it heal over time because we have eliminated CFCs globally.
That is a great example of how, we can take action. Yeah. So the extreme heat we're talking about not only melts ice and causes sea levels to rise, but it also increases ocean temperature, which can have serious impacts to our ecosystems. So let's check in with marine scientist Dr. Ivana Sechenik here at NASA's Goddard Space Flight Center to get an update on how heat has been impacting our oceans.
Hi, my name is Ivana Sechenik. I am a NASA oceanographer working at NASA Goddard and a space mission. An increase in heat on land system is not specific for the land system only. It affects the oceans, affects the life in the ocean, and is causing lots of changes that we can see. On one side, ocean traps this heat, but ocean does many other things for us. And this trapped heat and this trapped temperature, in a sense, is modifying the many things that we love about the ocean. So we have the dying corals on one side. We have the changes in the population of lobsters and shrimps and even manatees. But one thing that I care about is the way that this increase in temperature is modifying the services that ocean provides to the climate. Ocean, as I said, traps the carbon dioxide, but as oceans are becoming warmer, it can trap less carbon dioxide. That's your physical and chemical part. On the other side, you have phytoplankton, the teeny tiny plants of the ocean that breathe in this carbon dioxide. Well, what happens when the temperature is changing, that their community changes. So everything what they have done before, they're not doing it anymore. So now you have the completely different phytoplankton there existing there and modifying the way this carbon flows from the atmosphere into the ocean. So ultimately, that's what I'm interested in. I'm interested to understand how the future oceans, much warmer than today, are going to be modifying this carbon flow and where the carbon is going to go.
That is very interesting. Thank you so much, Ivana. So based on what we just heard, can you tell us how rising heat is impacting the ocean environment?
Well, one of the main issues that we're facing is a phenomenon known as coral bleaching. It's really coral death. In fact, right now we are seeing unprecedented levels of coral bleaching occurring worldwide. And that happens because as the ocean temperature rises, you reach a tipping point where coral can no longer live. So you don't see these vibrant ecosystems that you're used to when you see the Great Barrier Reef. Instead, the coral cannot live in those temperatures. It dies, it bleaches out to white, and you lose that integral part of the ocean ecosystem. Another thing that we're looking at with our satellites is a phenomenon known as harmful algal blooms or red tides. People along the west coast of Florida have had to deal with this several times in the past few years. And these red tides that we can are able to observe from our satellites in orbit, as well as ocean surface temperatures, these red tides are not only harmful for marine life, but they aerosolize a toxin that is then blown on shore by the sea breeze that is harmful for us to breathe. It causes a lot of lung irritation and eye irritation, even for healthy people. So we've been working very closely with our partners at NOAA, as well as with the state of Florida, to help to develop an early warning system for these harmful algal bloom red tide events so people know when it's a good day to go to the beach.
Mm-hmm. So are there any impacts we're seeing beyond the ocean environment when it comes to warming oceans?
Yeah, I mean, the ocean, it's a big part of our planet, and it plays a really important role in Earth's climate. So the ocean absorbs carbon dioxide and heat and mixes that up, and that impacts temperature and carbon dioxide all over the Earth, including over land. And there's also an important roles around water cycle, so we're seeing more heavy precipitation events over land. And the ocean just really plays, it's a part of that overall Earth system, and what happens over the ocean impacts us everywhere.
Yes, as Kate said, you know, a warming ocean evaporates more water into a warming atmosphere that can hold more water, and that has to come down somewhere. So many times, of course, it's over land. So we're seeing these extreme types of flooding events occurring again, many times just this past week, again over southern Florida. We actually have a satellite on orbit called the Global Precipitation Measurement Mission, or GPM. That's in partnership with our Japanese space agency partners, that we're actually able to measure precipitation across the globe and being able to investigate and monitor these real-time extreme precipitation events and floods.
So in addition to studying precipitation through GPN, how else does NASA study the oceans?
We have a number of satellites, and we've actually launched 2 just in the last 18 months. One of them, called Surface Water and Ocean Topography, is helping us understand the surface waters, so oceans and also inland rivers and lakes, and tell us how much water is running through those rivers and lakes, as well as looking at ocean circulation. And then just a few months ago, we launched PACE, which John has already mentioned, but PACE is telling us more about what's living in the surface ocean. So it can tell us a little bit about phytoplankton, give us information on harmful algal blooms, on fisheries, as well as on climate.
Yeah, PACE is a truly revolutionary ocean color instrument, and we just got our first light products from PACE just a couple months ago. I'd encourage people to go look at them online. They're really stunning images that we're getting from that satellite.
Mm-hmm. So we hear a lot about how El Nino and La Nina play roles in the ocean temperature, which also impacts weather. So how do they factor into what we're talking about here?
Yeah, so El Nino is a warming of the surface waters in the Pacific off the coast of South America. And its counterpart, La Nina, is when you have a cooling in those waters off the coast of South America. It is part of a natural Earth cycle, and it affects weather all across the globe. For the past couple of years, we've been in the El Nino cycle, and for our viewers here in the United States, you probably recall back in the fall and winter hearing of these major atmospheric river events occurring on the Pacific coast, where we had very heavy snowfall, very heavy rainfall, landslides. El Nino makes those things happen, where those become much more common to impact the West Coast. We are now, just in the past basically month, are flipping over into the La Nina cycle. And La Nina, of course, also has effects globally on our weather. More importantly for this summer, with us going into this La Nina cycle, we're going to have a decrease in wind shear across the Atlantic basin. Wind shear is a change in wind speed and direction as you go higher up in the atmosphere. Hurricanes don't like wind shear because it tears them apart. So what we're having this summer is we're going to have a very hot Atlantic basin. The ocean temperatures in the Atlantic are near or above record highs, along with an environment, because of La Nina, of low wind shear. This can make for a very dangerous and very long hurricane season across the Atlantic, Caribbean, and Gulf.
Yeah, in addition to those extreme weather effects that John described, we're seeing, El Nino years tend to be warmer on average, La Nina tend to be cooler, but then we have a background of climate change and increases in temperatures overall. So just as an example, 2022 was the warmest La Nina year on record. So La Nina, normally cooler than average, it was the warmest La Nina year, and at the time it was tied for 5th warmest. 2023, where we entered into that El Nino phase, was the far and away the hottest year on record.
So we have a few questions coming in online. Thank you everyone for sending them in. Keep them coming. So we have a question from YouTube, and they ask, what would happen if all the ice melted?
So there's a lot of water contained in the ice, and when the ice is over land, when it melts and runs into the ocean, it increases the volume of ocean. So we would see very, very extreme levels of sea level rise.
Yes, I mean, I think we've seen estimates that if all of the ice in our polar regions melted, and the Greenland ice caps, the Antarctic ice caps, and so on and so forth, it would be, I believe, a rise of over 200 feet in sea level globally. We're not saying that's going to happen because that's a very extreme event, but if you actually were able or did melt all the ice, yeah, you're looking at a very different landscape of our shores and continents.
Mm-hmm. So we have a question from Moses Katuku on Facebook, and they ask, are we going to experience another destructive, mighty El Nino?
El Nino and La Nina, it's a natural cycle, and every few years we shift from one into the other, and so we're entered into La Nina now, but we would expect in a few years to go back into an El Nino phase with all of those changes that come along with it.
Absolutely.
Okay, so we have a question from Ashoka Maruya on YouTube, and they ask, is thermal expansion of the oceans a significant factor of rising sea levels?
It is a factor in rising sea levels, and one of the things that NASA actually does is we look at sea level from a couple of different factors that contribute to it, and we provide that information publicly. So we can look at the contribution of melting of ice sheets, of thermal expansion, of changes in, we call it vertical land motion, but changes in how high the land is, and look at each of those individual factors and see how much they contribute where you live. So we have a sea level change portal where you can go click on a city or location along the coast and see how much thermal expansion has contributed where you live.
And exactly, as Kate said, these are all compounding factors. I mean, so you have, of course, the melting ice issue, you have the thermal expansion issue, and you have this land subsidence issue. And unfortunately, in some of our most vulnerable areas, like southeastern Louisiana, we're having land subsidence occur at a much higher rate than average. So again, it's just compounding the sea level rise issue at the same time in those places.
Thank you. So the effect of ocean warming include sea level rise due to thermal expansion, coral bleaching, accelerated melting of Earth's major ice sheets, and intensified hurricanes and changes in ocean health and biochemistry. It really is all connected. So can you explain to me, how is NASA able to combine the data to explain all of that interconnected systems and how they're working together?
One of the ways we combine all these is through models. So these are mathematical models. So we use a computer and we put in our understanding of the physics of the Earth system and all of its different parts. And then we can look at how they're interrelated. So we can represent the land, the ocean, the atmosphere, water, emissions, and put all of that into a single computer model, and then use the observations that we get from our NASA satellites to help us better understand how that changes over time. And then from those models, we can then look at the individual drivers in the past and the processes that are contributing to the changes we see today, and then we can also use those to project into the future.
Yeah, it's really a system of data, and it's a tremendous amount of data, not only that we're getting from ground sensors or airborne campaigns, but we're downloading almost 25 terabytes of data every day on the Earth system and how it is changing from our constellation of Earth-observing satellites. And so in order to understand this just treasure trove of data, we really have to have these remarkable model predictive capabilities that we have at NASA along with our other partners.
Thank you. I'm learning so much today. And thank you for all of this insight and for all of the data. So let's check in with another climate expert, Dr. Kerry Kals-Nicholson at NASA's Jet Propulsion Laboratory in Pasadena, California, who's going to give us an update on the connection between heat and air quality and the detrimental impact it has on humans.
I'm interested in air quality from the perspective of urban heat. I work on an instrument called EcoStress, which studies surface temperature from the International Space Station. One of the things we're really interested in is the urban heat island effect. So in cities, especially cities that have a lot of cement and concrete, those cities get hotter during a heat wave, but at night they don't have a chance to cool down. And so the next day, things just get hotter and hotter and hotter. And this has significant health impacts, but it also has a real impact on air quality. As you know, people tend to run their air conditioning units when it gets hot, and this contributes to emissions. We know that heat waves are becoming hotter, they last longer, and they're becoming more frequent. And so we're concerned about the long-term impacts to air quality as a result of heat waves. EcoStress is especially interesting to study urban heat because it has a very fine resolution. That means that we can zoom in to individual neighborhoods, since we know that individual neighborhoods each experience heat differently. And we're working with city officials and city planners to see what we can do to mitigate the impact of heat in our neighborhoods.
Thank you, Kerry. So, Kate and John, can you explain what NASA is doing to help inform local decision makers about heat and air quality?
Well, I'm going to focus on one particular aspect of air quality and heat, and that is on the issue of nitrogen dioxide. Now, nitrogen dioxide, NO2, is a harmful pollutant to breathe on its own. It's a regulated pollutant by the EPA. It comes from smokestacks and tailpipes, so cars and factories. So it's extremely concentrated, particularly in our urban areas. Now, with nitrogen dioxide, once you expose it to heat and sunlight, it breaks down into ozone. And we mentioned ozone earlier because we love ozone up in the stratosphere, where it protects us from the sun's UV radiation. But we don't like it down here at nose level where we're breathing it because it causes a lot of lung irritation, throat irritation, particularly harmful for those who already have pre-existing conditions like asthma or COPD. So as you can tell, this urban heat island effect is actually creating and generating ozone, particularly during rising heat events and heat waves. And that leads to these red alert air quality days that people probably hear in their cities, where they're encouraged to take public transportation or not gas up their car that day because their level of ozone is too high. Now, luckily, last year, we launched a brand new satellite into orbit called TEMPO. And TEMPO is looking at the very air we breathe across the United States every hour of the daylight at unprecedented resolution, down at the neighborhood scale. And TEMPO observes nitrogen dioxide. So we're being able to watch nitrogen dioxide, how it forms during the day, where it moves, where it's going, how is it different from AM rush to PM rush, and sharing that data with our partners, such as with state air quality departments or the EPA, for them to better understand and monitor the health of our atmosphere.
That sharing of data is really important to us at NASA. So we share TEMPO data, we share data from all of our missions, and we're working not just to make it publicly available, but to make it easier to use so that people know what's there, know how to find it, know how to use it, and can understand what's happening where they live.
It's so great that NASA data can be used in this way and have real benefits to life on Earth. So, as temperatures on Earth continue to rise due to climate change, heat waves are expected to get hotter and occur more often. As Kate and John have both mentioned, urban areas that have more buildings and roads and less natural landscapes and vegetation will be impacted more severely by those heat waves and their associated health and environmental effects. So what solutions are there to combat some of these issues when it comes to heat and air quality in urban areas?
Well, the number one driver of rising heat in urban areas is rising heat on the planet in general. And so to limit the warming in our urban areas, we have to limit the warming overall. But there are some local things that people are doing now and that we can observe the impacts of in an urban area. So earlier you heard a little bit about eco-stress. So one of the things that eco-stress can do is look at temperatures at a very high precision in urban areas and see where it's hot and where it's cool. And then also look at how the activities people take in those cities change those temperatures. And so I think we have an image, but looking from eco-stress at an area in California, and there's actually up now for the readers, so I'll actually walk through it. If you look at the area that's in that green polygon, that is an area where they have painted the street with a reflective paint. And as a result, that street is cooler than the surrounding neighborhoods. And we can see that from space. We can see the temperatures of that urban area, and we can see where it's cooler.
So as Kate said, on the margins we can affect it. And I mentioned earlier there's some actions that people can take, such as rooftop gardens, or encourage your buildings to have rooftop gardens, while also expanding green space in our city to help have areas where people can get cool and cool the environment in general. But another thing that needs to be thought of is the location of cooling centers where people can get out of the heat. NASA did a project several years ago with cities like Cincinnati, Dayton, and Phoenix, where we actually took temperature observations from our Landsat satellite, which is a NASA USGS joint satellite. We got very high resolution temperature data, so we could plot where were the real hot spots in the city. So those cities found out that sometimes their cooling centers were miles away from where really the hottest part of the urban core was. So they could have them better located so people could have easier access to get in and out of the heat.
So we have some questions coming in from the public. Thank you again. So we have Car Guide number 2 on X, and they ask, does launching all of the rockets into space have any effect on our atmosphere?
So rocket launches do have short-term impacts along the launch trajectory depending on the type of propellant used. So there's different types of fueling a rocket, and they have different impacts. Those impacts are small compared to human activities' impact on climate change today.
Okay, so Gregory D. Barney on Facebook asks, if carbon dioxide is a natural byproduct of life, how is it possible to reduce the carbon emission to zero?
So when we talk about reducing carbon, you might hear the phrase net zero or reducing carbon dioxide emissions to zero. They're usually talking about human-caused carbon dioxide emissions, or what scientists would call anthropogenic. So the carbon dioxide emissions associated with combusting of fossil fuels or other changes in the landscape. And when you get that to net zero, meaning that any positive emissions from human activities are balanced by removals, that would limit warming. Okay. But it is emissions, not concentration. So we're talking about how much more carbon you put into the atmosphere rather than the amount that is in the atmosphere.
Thank you. Thank you for the clarification, because I know that is a common question that we get. So at NASA, we have an array of facilities across various climates, from our headquarters in Washington, D.C., Kennedy Space Center in Florida, to the sunny west at NASA's Jet Propulsion Laboratory, or JPL, in California, which is why we must consider how climate change will impact our own infrastructure. So now let's turn to Tom Nicholas at the White Sands Test Facility in New Mexico to learn more about how NASA is preparing for the future.
Heat can have a cascading effect on all communities. At NASA, the White Sands Test Facility, also known as WSTF, located in the southwest New Mexico desert, we get plenty of sunshine, but only about 8 or 9 inches of rain per year. Because of these environmental factors, we're always planning for the future and thinking about how to secure our facility so we can continue to meet our mission. As the energy manager here at WSTF, it's my job, along with the NASA Facilities Engineering and Sustainability team, to work with these unique issues to develop projects that can help improve carbon-free energy production, water conservation, and resiliency. To combat these issues, we are taking advantage of our hot, sunny days to develop and expand on our photovoltaic generation and battery energy storage yard. In addition, we're making improvements within our site and testing areas to reduce water consumption, with a large altitude test stand water recapture project. To improve resiliency, we are constructing a microgrid that will independently power our site's water system, helping us to conserve water. WSTF will continue to strive for environmental improvements to increase our sustainability efforts.
Thank you, Tom. The impact climate change has on managing facilities and communities seems very vast. So, Kate and John, can you expand on what NASA is doing to learn more about this and providing decision makers with that data?
So one of the things about NASA is we have centers and facilities all across the country, and each of those are facing different impacts now, and we know that with future warming, those impacts will increase. And so we're taking steps now. You heard about some of those in the video. At Kennedy Space Center, which is a coastal facility, we actually are doing mangrove replanting and sand dune restoration to protect our infrastructure and facilities now. But when we think about the future, we need to know what's changing and what are those impacts might be in the future. So we actually have a project where our climate scientists work with our infrastructure teams to talk to them about what might happen, and so they can better prepare. And that also helps us as scientists understand what information is needed for decision making and how to get that so it's in a more easily accessible form. And we've been putting trainings out on our website so people can understand what we're doing and how they can use that information as well.
You know, we talked a lot about today about how our data is completely free, open access to everyone across the globe, and how we're doing all these projects to get that data into the hands of people to make decisions. But we are the users of that data as well, not only the producers of it. And so that's a really cool aspect, that we're actually at NASA using this data to help understand the vulnerabilities of our facilities and how to mitigate those vulnerabilities. Because as Kate mentioned, many of our facilities along the Louisiana, Mississippi Gulf Coast, and the Florida East Coast are in some very vulnerable areas.
So we have some more questions from online. Marcus on YouTube asks, how much impact would switching our grids over from coal and natural gas to nuclear have on lowering our emissions?
So one of the major drivers of climate change is carbon dioxide, and one of the major contributors of that is from electricity grids. And I don't have the exact numbers on me right now, but that is something that scientists do look at, is how much more warming will we get from the grid we have now, and what would future energy systems mean in terms of warming.
Mia from Virginia asks, what advancements on the International Space Station help us with sustainability on Earth?
Oh, this is we also live and work in space, and so we have astronauts that are currently living on the International Space Station. And one of the things that NASA does is we think about what they need to survive off the planet Earth. And as a result of that, those things that we have to develop for crew living on the International Space Station can also help us here on Earth be more sustainable. So just as one example, our astronauts grow crops on the International Space Station. And we have done a lot of research into LED lighting and fertilizer applications and types of fertilizer in order to grow those crops in space. And those can be used all around the world here on Earth for indoor agriculture facilities and to help us improve our farming.
You know, the International Space Station has just become this amazing Earth science laboratory, a continuously crewed Earth science laboratory in orbit that has lots of sensors on board that are giving us, again, information on the Earth system and how it is changing. That includes, for example, eco-stress that was mentioned earlier, looking at plant health, for example, across the globe. But there's another sensor on board the International Space Station called EMIT. And one of the things that EMIT can do is look at methane plumes across the planet. And we talk a lot about carbon dioxide because it's the most common greenhouse gas, but methane is by several factors times a more severe greenhouse gas, and it comes a lot from the generation of the oil industry, et cetera, and so forth. And so EMIT's actually able to look at these kind of super methane emitters across the planet to help us understand where they are, and that information, of course, feeds into our climate models.
All right, so we have time for one final question, and this is for both of you. So what advice do you have for someone watching today if they want to join NASA's efforts in studying our planet and climate change?
We have a lot of efforts underway at NASA in order to invigorate and inspire our next generation of scientists, engineers, and explorers. And that includes a very vibrant intern campaign that I encourage people to look into. And in particularly in the Earth Action Program where I sit, we have a program called NASA Develop. And NASA Develop is a program that allows college undergrad and graduate students to be able to work directly with NASA Earth scientists at centers all across the country to use the Earth observations we've talked about today to help tackle local problems.
We also have a lot of citizen science projects where people anywhere all around the world can help us do science just from their home, often with just a cell phone. So we have one project called NemoNet where you can play a game on your phone where you help us categorize coral reefs. There's another one called the Globe Observer app where you can help us better understand clouds, and you can do that just from your home.
Yes, that's right. There are many projects that the public can participate in from their own homes. So to learn more, visit go.nasa.gov/citizen science. Thank you both so much for joining me today to discuss this incredibly important topic.
Thank you, Joy.
Thank you.
And thank you to everyone online for watching. To stay up to date on climate science, follow NASA Earth on Facebook, X, and Instagram. Remember, from space, the skies, seas, and land, NASA provides detailed climate data and research to the world. All of this data is freely available to anyone. To access this information and more, visit climate.nasa.gov. If you can't get enough of Earth science, we have a special treat for you. Let's take a peek of a new video that will take you inside NASA's PACE mission. This is an Earth-observing satellite, which is helping us learn more about our ocean, its role in Earth's climate, the creatures that live there, and more. Visit NASA's Goddard's YouTube channel to watch that full episode. Thank you, and see you next time.
There goes PACE.
Humans have never had a data set like this.
NASA's PACE satellite is showing us the colors of the ocean like never before.
And liftoff.
By being able to see the diversity of the phytoplankton, we're going to be able to model much better where that carbon is going.
I'm going to slide it under and we're going to see what we're going to see. Some party people.
Yeah? Oh, wow. Okay.
So what you're seeing here, it's called a diatom.
You guys both also have ties to the ocean. So I know, Bridget, you surf?
Yeah, that's right. I am a surfer. In terms of surfing and water quality, PACE is going to be great.
From a single satellite, we get to learn about water, land, and air as we continue to monitor Earth's changing climate.
It's a new era of pioneers, star sailors, thinkers, and adventurers.
3, 2, 1, 0. All engine running.
Let's go.